Hello and welcome back to the course
Fundamental of Electronics and Electrical Engineering.
In this video lecture, I am going to discuss the topic source transformation technique and finally network simplification technique which is used to reduce complex circuits. So let us start. Source conversion technique basically used to reduce the circuit simplicity. Using the source conversion, we can convert a voltage source into the current source and current source into the voltage source. So a given voltage source with a resistance in series can be converted or can be replaced by equivalent current source with a parallel resistance. Resistance is always series in voltage source and it is in parallel with current source. So, and inversely we can say current source with a parallel resistance can be converted into the voltage source with a series resistance. So both side conversion is possible. Now, here you can say there are two terminals A and B, and between the two terminals, voltage source V is connected in series with R. Now, this network can be converted into the other network which consists of current source. So, current voltage source is converted into the current source and it is in parallel with resistance. Here, voltage source is in series with the resistance, so voltage source is in series with resistance. Here current source is in parallel with resistance. In both the cases, value of the resistance are equal. Now what is the condition? The condition is that open circuit voltage and short circuit current in both the cases should be equal. Means the voltage which we are getting over here between A and B and the voltage which we are getting between these 2 points should be equal, and short circuit current between A and B in the first circuit and short circuit current between A and B in this circuit should be also equal. Now what is the value of I? Resistance R are equal in both the cases. Now what is the value of I? So here I is equal to V divided by R. So this is how you can convert a voltage source in series with resistance into the current source in parallel with the resistance. Now here resistance, as I told you, are equal in both the cases. Now one example based on source conversion technique. So in the given circuit, we have to convert voltage source into the equivalent current source. So here one voltage source is there, that is the value of that voltage source is 10 volt. It is in series with 5 ohm resistor. Now this network we have to convert into the equivalent current source. So we know the series resistance becomes the parallel resistance. So this circuit can be converted into this circuit. Here 10 volt voltage source is converted into ampere current source, and in both the cases resistance are equal. So series resistance becomes the parallel resistance and both resistance are 5 ohm. Now what is the value of current source? So it is given by I is equal to 10 by 5, that is 2 ampere. Short circuit current we have to determine over here. So short circuit current is nothing but the 10 by 5, that is 2 ampere. So 10 divided by 5 will be a current source and the value of the resistance will be equal in both the cases. So this is how you can convert a voltage source in series with the resistance into the current source in parallel with the resistance. Now current source to voltage source conversion. So here one circuit is there, figure A, which consists of current source in parallel with the resistance R internal, that is the internal resistance of the current source. Now this network can be converted into the equivalent voltage source. So the voltage source E is given by Is into R integer, R internal, where Is is a source current and R internal is a resistance which is in parallel with the current source. So equation becomes E is equal to Is into R internal. So this is how we can convert a current source into the voltage source, and here also the resistance in both the cases is equal, that is R internal. So basically a source conversion technique is used to reduce the circuit complexity. This is the network simplification technique. Voltage source to current source conversion, current source to voltage source conversion. Now let us see other network simplification technique. So here you can see two voltage source V1 and V2 are connected in series. Now that can be converted into the equivalent voltage source V1 plus V2, because when voltage are connected in series, both are added. Now here the sign of the V1 and V2 is plus minus, so equivalent source voltage sign will be also plus minus. Next one, V1 and V2 is there, but polarities are different, you can see. So the equivalent voltage becomes V1 minus V2 if V1 is greater than V2. and it becomes V2 minus V1 if V2 is greater than V1. Now, polarity should be considered of voltage source V1 because it is having higher potential as compared to the other voltage source, that is V2. Now next one, two current sources are connected in parallel. So when current sources are connected in parallel, both are added. So here total current becomes I1 and I1 plus I2, and the arrow sign is in upper direction because both current signs are in upper direction. Now here in this case you can see arrow of I1 is upward direction and arrow of I2 is in downward direction. So total current I becomes I1 minus I2 if I1 is greater than I2, and the direction will remains of I1. If I2 is greater than I1, then it becomes I2 minus I1 and direction will be considered of I2. The next one is two voltage sources are connected in parallel. Now we know when voltage are connected in parallel, when resistors are connected in parallel, the voltage is equal. So here V1 is equal to V2 and polarity also remains same. Now if two current sources are connected in series, then both current sources are equal because the same current flows in one branch. So here we can write I1 is equal to I2 and arrow direction remains same. So this is all about today's lecture. In this video lecture, I have discussed some network simplification technique like voltage source to current source conversion and current source to voltage source conversion. Hope you enjoy the video. Thank you for watching.